Okay, this is 1 week later with Neco Autopilot. I've done some research and it's really interesting how the system works. This is the schematic provided by the manuals in those days. Now, this is the relay, the double-sided relay, and I found online a solution that a tech guy from those times did. Now, it is a little bit more comprehensible, maybe this drawing here. These two are the two relays contacts from one side and the other, and those are the connections for the whole system. And in like 20-30 years ago, this is the schematic of the system. The pieces you don't need anymore in order to reuse it. This one also, this is the drawing of everything. This is a power board from like a Simrad or something like this that used to command the whole thing, and you have the instructions on how to do it. Now, I don't have the page. We will work on this one. I already do the drawing on what's going on in there. Now, this is what's going on inside. In the original Autopilot, we have a plus, a positive, that it's going in. This is the stator winding that has a polarity, a plus and a minus. Then from the stator, it used to go inside one of these contacts here. This one, it's the one that's moving. So it's touching here. When it's on the upside, it's touching and is staying still. It's normally closed on this one. And whenever you energize the bobbin, we'll just go on the other one, we'll switch. This is a simple relay, like the most basic type of relay. When you apply 12 volt power, it will go like this. And this is the other one of relays. So the stator, it's always powered in this direction, plus to minus, and if you want to make it go like clockwise, you have to put this one here, so it'll close through here. So the negative will come from down, will enter this one will go up to the positive, and the motor will go clockwise. If you want it counterclockwise, you leave this one closed, apply power on this relay, the relay goes here, so the negative will come from here on the other side, the motor will turn around, and the stator is the same thing. Now, this type of motor, it's called a shunt motor with a winded stator, and the shunt, it's always powered whenever the motor, it is the clutch, it's engaged, the shunt, it's also engaged. Here we have a anti-parallel diode that it cuts a little bit of transients of the clutch and the shunt, but the shunt should always stay power. And this one is also polarized, it has a polarity. Now, from the original drawings, we can come up with the wires where they used to be. These are the two diodes, 1 and 2, the two capacitors, 1 and 2. This is the other diode, the clutch diode is this other one. Then you have a couple of fuses and stuff. Now, the solution they gave in those years, like 15-20 years ago, I don't know, not even how much time, it's take an Autopilot that has outputs, two outputs for the valves. Let me just grab a valve and show you what I mean. Now, on the big, really big, and on some of the older systems, you have a valve group like this one. This is a solenoid. This is a solenoid. And inside it has an hydraulic circuit. Whenever you engage one, it makes the oil go from one side to the other, and it moves a piston. Now these valves, whenever you command them, you have two wires on them, and it just turns on and off. It is not PWM commanded. This type of Auto Elmo 100, they have like a type of output when you can connect the valves. Also, you can do it from an S3. The S3 has also the solenoid outputs. Solenoid, when you take one wire from the solenoid, one wire for the B, the other wire of the solenoid with the other wire on the A. So you'll command the solenoid. Now, what is the first thing with those solenoid? The S3 Autopilot. It has the current limit and it has the PWM, the PWM signal. Now, whenever you have to watch your power draw, power consumption, you want it to be PWM, and you want the current limit, like for the Raymarine linear drives, the rotary and so on. Whenever the wave makes too much force on the helm, it will protect himself and go to current limit. In these situations, whenever you use the hydraulical valves or the relay commanded, instead of commanding the hydraulical valve, send power to the valve, send power to the relay. Whenever you have it like this, you have no current limit protection, and the power draw of the whole system, instead of having like a slow ramping up power, it just go up and down, and it draws a lot of power. Now, the second thing, you have a mechanical, either if this one, it is well built, because it is a quality, you can see it there, it is a quality relay. That flamed, but they consume, the contacts consume, the mechanical consumes, they can stay welded shut and so on. So I honestly don't like too much the system using this relay. Using this relay, you could also connect it on the small Autopilot, like an ST5000. This is a ST5000 that has everything inside. It is recommendable to use the rudder sensor also, but you can use the drive output even if it is not born to do this job. I'll show you how you can connect it to use it as a relay. Now, the output of ST5000 has drive and has A and B, like on the Smart Pilot. Only two wires for the outputs. In order to command two valve groups, or two relays in this case, you can use 4 diodes. You take from A and you put the anode, the positive, on one side, so the power, whenever it has the positive on A, it goes like this and returns on B, so it powers this one. When it inverts the polarity, so on A you'll have the negative, here cannot go because the diode is blocking it, but we'll go through this one and go back from here to the other one, there's positive, so it will power the left one. Same thing, you could do it using it for this relay and command one relay or the other. The difference is that an ST5000 doesn't know how to work with valve systems, so it will be PWM controlled, and you have to play a lot with the rudder gain and the response, and in order to make it, and the damping, in order to make it work decently on valve groups, because it doesn't have the software to work on the valve groups. The old 100 series could work like so and so, just a little bit on the things, but I honestly don't like this system. I would much prefer to have it connected in a way where you can take advantage of the modern electronics like the current limit and so on. Now we'll use some diodes, the same system. These are like solar diodes, Schottky, 15 amp each. In order to command the valves or the relay, you don't need them 15 amp power. You can even use them smaller power, the diodes. In this case, with this motor this big, I think we're gonna need like 2 of them parallel to 30 amps. Give me one moment that I do another drawing and I'll be back with you. Now this is the big idea. Instead of using the relays, we'll just use like 4 diodes. In this case there are 15 amps. We can use like 2 and 2 paralleled for instead of each one of them, or use bigger diodes like 30-40 amp diodes. These ones have a low power drop, the solar ones, so you don't lose a lot of power in heat inside the diodes. The idea is it goes from A whenever it sends, like let's say it sends the positive, it goes from A, it goes here cannot pass, but it will pass through here and it will get here, so the stator will get the plus, then will go on, the plus is going here, and the motor will go one way, will have the plus here, and we'll do it like clockwise, and this is the other terminal. When the power inverts on the A and B terminals and you have the negative from here and the positive that's going from here will go through the motor, so you'll have the positive here this time, so it will go the other side. Now we'll go through this diode still to the positive of the stator, because the stator needs to have this one positive and this one negative. You cannot power it the other way around. The stator will just go slowly, and in this way you can use the A and B motor output and say it is a linear T2, a T2 linear drive. So you can use the whole 40 amp power and you'll have the current limit whenever the helm is blocking. For the other part, in order to power the shunt and the clutch, the shunt, same thing, needs to have a positive and a negative, and you cannot put them the other way around. So all you have to do is connect the clutch wires the correct way, positive and negative. Now I don't have much time now. I'll have to go to the medic because I'll just show you what happened. Ow, 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 ow. A battery fell on my foot, so I broke myself 3 fingers. Triple fracture. Anyway, now I'll have to go to the medic. One of these days we'll just grab the diodes, we'll connect everything, and we'll see it work. But as an idea, will be a motor that it consumes a lot of power. I had another idea. Instead of using this big mess of a motor, why not using either a normal new DC type of motor, or use even better solution, use a new efficient brushless with electronics, so as a much smaller brushless with a gearbox connected directly on the shaft. All you have to do is build like a custom plate instead of the motor that will keep the worm gear, and attach a smaller motor. In this box you could keep all the electronics inside, and that would be a much more efficient system to redesign. But maybe it's easier to redesign it from scrap. It's a pity, because this one, it is a really lovely mechanical job on the down part. Now here in this one there is a small encoder, a potentiometer, a pot, a variable resistor. yeah, 500 ohm resistor, and it has two limit switches. So if you decide to make it work like with a stupid ST5000 and you don't have the how is it called, the rudder sensor on the boat, the 5000 will work with no rudder sensor. The problem is that whenever it reaches the end of the line, will keep pushing the motor and will force all the system. You risk burning the MOSFETs inside and fuck up the autopilot. In this case, if you use one of these, you can use the end of the line switches to interrupt the power. So whenever it reaches the end of the line, you cut the power and will not go any further. If you power it the other way, will go the other way around. Also using a couple of diodes. Anyway, I hope you like it, and whenever I get to, we'll get back to it and try to do the diode modification that I like it a lot better.